Okay, question 20. For how many values of a is the equation x minus a times x squared minus x plus a equals 0 satisfied by exactly two distinct values of x? Okay, so let's observe the equation. Yeah, there's x minus a as a bracket, and then there's a x squared minus x plus a as the other bracket. All right? So we definitely know from the first bracket that a is a root, no matter what. Yeah. So what we're going to do is that we need to make sure that this guy also has a as a root, right? Then we get two a's, which is great, right? Because then you get repeated a's, so you only have two distinct roots at the end. Because this is a cubic, right? This whole thing is a cubic, so you would expect three solutions, right? So with three solutions, if two of them are the same, then at the end you get two distinct values of x, right? So we need to make sure that a also solves the second guy, right? So a squared minus a plus a equals 0. Cancel, cancel. A squared 0, so a is 0. Great. So, and then people would answer 1, right? One value of x. No, one value of a, sorry, which is a equals 0. Yeah. But then, the issue is that the repeated root does not necessarily have to be a, right? I mean, you're assuming that it's ax, right? But why couldn't it be axx, for example? Yeah, maybe this quadratic gives you repeated roots, right? Okay, so if the quadratic gives you repeated roots, what does that mean? That means the discriminant equals to 0, right? So discriminant b squared minus 4ac, so 4a is 1, c is a, so 1a is equal to 0. Right, that could give you repeated roots, right? So a is a quarter. I mean, the value of a doesn't exactly matter, right? But just for the sake of completeness. So, you know, if you go a is a quarter, then a quadratic gives you repeated roots. Yeah. So a equals 0 or a equals a quarter. So therefore, two values of a does the job. Yeah. So be careful.